So hello friends, Shivansh this side, and today we are going to derive Frenet Serret formulas. And these are three formulas which are very important in differential geometry. First one is that dt by ds, mouse problems. dt by ds is kappa times n, where kappa is curvature and n is normal vector. And so we are having three formulas like this, and we'll be proving all of them one by one. So let's start with this one. So to prove this, like this is a very simple formula kind of thing. So to prove it, what we simply need to do is basically apply chain rule. That is dt by dt into dt by ds. Now dt by dt is t vector dash, and this is dt by ds. And dt by ds is basically 1 by ds by dt, and ds by dt is mod of r dash. And this is the first thing which might be non-obvious in this whole video up till now. So okay, where were we? Okay, so this is the thing where kappa is curvature. I will be telling you its formula. So dt by dt into dt by dt is chain rule, dt by dt is t dash, and now what I'm going to prove is that dt by ds or ds by dt is r dash, mod of r dash. To prove it, basically we have to apply a very small simple thing. Let's say it's a vector kind of thing, x y, and this is x plus dx and hence y plus dy. So corresponding vector is dx I cap plus dy j cap, and dy j cap. So what is not basically dy, it's f of x plus dx kind of thing. So I hope you're understanding what I'm trying to say. I'm trying to say that it's f dash x into dx. Now if I take its magnitude, then we get root of 1 plus f dash whole square. And if you notice, if you realize, what is this thing? This is basically small displacement, okay, and small displacement and divided by dx, okay. And this is what this is basically x plus f and f dash x dash. So we say it's r dash, and this is the thing I am saying, that this formula stands for here. So what we have now is t vectors dash, which is basically a dash of tangent vector, t vectors dash by mod r dash, mod this is it for now. Like we've done this. Now what I'm doing, I'm multiplying and dividing mod t dash vector up and down. And what its motivation is that to make some feel of our normal vector. And from definition of radius of curvature, so t dash by r dash is t dash mod by r dash mod is kappa curvature. So this thing whole becomes kappa, and this thing is n vector. Let me help you making out sense of it. Of course n cap you can also write because it's a unit vector. So t dash, sorry, t vectors dash by mod t dash into kappa, okay. So what I am trying to, like, what I will try to make you convince is that the vector, the t dash vector is parallel to our n vector, is parallel to n, because if it is true, then its unit vector is simply n into kappa times, and we got kappa from this thing, t dash by r dash mod. So to prove it, what we know is, first of all, what is t? T is tangent unit vector. It is r dash by r, mod r dash. Okay, where r dash is like for a position vector, its derivative with respect to time, of course. Okay, basically not time with respect to parameter. Okay, so I am now doing. I am writing that t dash like t dot t is what is a constant which is 1 because this is t cap, this is t cap, and every vector is parallel to each itself, so it's 1. Now I'm taking derivative both sides, which makes dt dash by dt dot t is 0, and which convinces us that t dot t dash is 0, which means sorry t cap, not t dash, it's t cap, which means that t and t cap are perpendicular. And if t and t cap are perpendicular, then t is normal vector. It's along normal vector of this thing, and hence we prove first of the solid formulae. Now second thing is our dB by ds is negative tau n, where tau is known as torsional constant of a curve, and it's only defined for curves which are in 3D. Okay, so first of all, to understand that what b vector is, let's consider a curve. This is a curve. Okay, now at this point we have a tangent vector. Let's take this point. We have a tangent vector, we have a normal vector. So b is a known as binormal vector. It's a vector which is defined as t cross n. T cross n. Okay, so our second formula from, I forget this guy's name. Ferret Sonnet. Ferret Serret. Is that d cross n by ds is minus tau n. And to prove this, I'm first of all applying product rule, that dt by ds cross n plus t cross dn by ds, this whole is r dv by ds. Okay, now what I'm saying, that this thing is 0. Of course they are vectors. I'm saying that this thing 0, and like after this, the basically these all are proofs which are thought by me of this thing, and many of the things I'm trying to think fresh over here. So if this is our tangent vector, so, and this is our normal vector, so t dash vector lies over here, and here lies our b vector. So basically dt by ds, if we multiply d above and below, we get t dash vector, and dt by ds is itself a constant, which is we call as r dash 1 by r dash for this case. So this means this becomes 0 because its vector cross with itself is 0. So what we have now is t cross dn by ds. T cross dn by ds. This is dB by ds. Okay, so for dn by ds, I'm again doing the same thing, multiplying dt above and below, we get 1 by r dash t vector cross dn vector, dn by dt vector precisely. Now, if this is my t vector and this is my n vector and this is my b vector, then this is t dash. Now, by symmetry, if like a tangent is normal, like for two curves, it can be possible that this is tangent, this is normal, and at another point this is normal, this is tangent, or a line parallel to it, it's normal. So basically, what I'm trying to say, by symmetry, n dash lies along t. Sorry, not along t. I think along b, because t cross n is b. Okay, so it's lying along this thing, and hence we can say, like, by taking mod both sides, it's kind of something which is parallel to n. Yes, t cross n, t cross n dash, it goes till here, like it goes here. I'm still trying to think that why it's going pretty wrong, because I am still in an intuitive way. I'm thinking that n dash should be perpendicular to this, but I think it would be here, or else this equation wouldn't have been making any sense. Let's try to think, if this is b, taking derivative with respect to t, let's say dB by dt. Yes, it seems to be. Anyways, let's go on to our third formula. Let me tell you one thing, that t cross n is b. T cross n gives b. So if all three are unit vectors, it also implies that each other crosses give other thing. Like b cross t gives n, n cross b gives t. So we write one equation for n. N is b cross t. And now, taking derivative, we get our third Serret formula. And this is it.